Hello world, this is Joanne, and today I wanted to talk about something that gets me really excited. That is adaptations. It's a word that a lot of us use and throw around. It's a word that often has misconceptions when people are trying to translate how we normally use it in everyday parlance to how we use it in the classroom, and it's something that comes with a lot of misconceptions. At the same time, it's one of my favorite topics. I've worked a little bit with adaptations in some of my ecology work, and it's just a really fun area and a place that I really enjoy being at. So today I wanted to talk a little bit about how we can define it, and I have a few different resources that help to elaborate adaptations and help to kind of solidify for students how they might be able to think about it. So first off, one of my favorite resources is from Berkeley. They have a whole website dedicated to understanding evolution, and they talk more about evolution related topics such as ecology related things. I mean, they're kind of sister studies right there. They go together all the time, and so they have a lot of really helpful resources in being able to think about words and terms that are often misconstrued. So one thing that I often like to stress with students is that there are words that we use in everyday situations in our everyday life that sometimes don't always mean the same thing when we walk into a science classroom. You'll find the same thing with lots of other subjects. Something you say here doesn't mean the same thing when you walk into a group of a bunch of economists or a bunch of accountants or a bunch of mathematicians. Whatever it is, there are often terminologies that we use in one way in a certain context, but we don't use necessarily in the context of its field. And adaptations is one of those words. So usually when we use the term adaptations, we're often thinking about a change. We're often thinking about something that you learn, something that you do, something that you grow, how you change and adapt to a new situation. However, when we're using that same word in ecology or evolution or thinking about the natural world, it's not often tagged to something that you just learn or do. It's funny because we often do learn in biology classes. One of the first things you learn about when learning about evolution is talking about how Jean-Baptiste Lamarck once had his theory about giraffes stretching their necks longer, and as they stretched their necks longer, their kids would have longer necks, and that's kind of how he thought that genes and heredity worked and how those things passed down. And that really, I think, in some ways also sums up how we often think of adaptations. We think of it as something that you kind of learn and do, but when we think of adaptations, it goes again with that idea that it's not that the giraffes are stretching their necks and that's what's being passed down, but rather that those giraffes have long necks, and those giraffes that have long necks are surviving. And those long-necked giraffes, that long neck is an adaptation. And in that, giraffes with long necks, they are born with that trait. They are able to use that trait, right? So their necks function, they actually can use it for what a long neck is for, and also it helps them to survive and reproduce, and that surviving part and that reproducing part is really what helps affect change. And as generations go on, we see our long-necked giraffe surviving. And so one thing that I think is really helpful with adaptations, again, comes from the Understanding Evolution site that Berkeley has specifically for defining adaptations, and they do take you through those three things. They take you through the importance of an adaptation being heritable, so something that has to be passed down through genes. They take you through the fact that it has to be functional, so there are many vestigial things that organisms have that don't necessarily work. I have a tailbone. I don't know how effective it is at helping me to reproduce successfully or attract a mate or survive, but I have it. It's just not necessarily functional. So there are some examples of that we can see in nature. And then finally, of course, fitness, and that's again another one of those words that is different how we say it in the real world versus how we say it in science and how we think of it in its context in ecology. That fitness is about being able to reproduce and survive. And so those are the three main metrics that they use to define adaptations, and I think that's really helpful when we think about science literacy to think of almost like mantras or steps or formulas that we can help students use to help integrate and analyze different vocabulary. I think sometimes when we use vocabulary, it can be difficult because there's a lot of nuance in science, and I love nuance. I love explaining everything overly all the time. But sometimes it can be a bit much for students to be able to comprehend all at once. And so I think it's really helpful to kind of go through this like tripartite system where we think of three important aspects when analyzing whether something is an adaptation or not. So, all of that said, one other thing I did want to note is that there is an interesting field called mimetics, used to kind of maybe describe those heritable elements that aren't necessarily genetic, but that we do see passed down from generation to generation. Because I know while I was talking, and perhaps while you've been sitting in your own science classes, you thought, well, I mean, how do we learn to, have certain interactions with each other? How does the monkey teach its little monkey how to use the coconut tools? Or how do different animals learn to kind of socialize each other? And I think there's still kind of discussion about what those are, but I think one interesting field that offers maybe some relation to how we can think of adaptations, but through non-inheritable ways, are in the field of mimetics, which is kind of more of ideas being translated down through generations. And I think it's a really interesting topic. I won't talk a lot about it today because I haven't gone super into it. I just know that that is something that maybe some of you thought about and might be interested in. And so I think that's just one of those cutting edge things that you can maybe talk about with your students, or maybe research more and get back to me, because it's really cool. And it's always fun to have more nuance when we have these discussions. It's always important to show kids that, these things are conversations that are still happening right now. But back to this current conversation. So adaptations, once again, are things that are heritable, they're functional, and they contribute to an organism's overall fitness. And so I have a few different resources that I would like to share with you all, and hopefully you'll be able to take those and run with them. I really like sharing things and hoping that you kind of take it and adapt it. So I have a few things that I like to call lesson seeds, where it's not a full lesson plan, because the way I think of lesson planning, I often think about it in compartments, and this often will change depending on my students' needs. And so I might have little pieces here and there that I kind of hodgepodge together to make for different situations. Really screechy hawks in my backyard. I don't know if you can hear them, but they're really screechy right now. Anyway, so the first thing that I have is actually a worksheet that kind of does go through helping kids identify those three aspects of an adaptation. And some of these things are a little bit harder than others. Some are easier. Let me look really quick, because otherwise I'm going to forget myself. But again, I kind of just lay out different situations in which students have, such as, for example, a dry, scaly skin. That's a possible adaptation. And there's an explanation that the dry, scaly skin of a Gila monster helps it to prevent water loss in the hot desert heat. So students are given a situation, and they then are tasked with being able to decide, well, is this heritable? Is it functional? Does it help the organism survive and reproduce, that is, contribute to its overall fitness? And if all three of those things coincide and are a yes, then yes, it is indeed an adaptation. And again, these things aren't always perfect, so there might be students that disagree whether something is actually functional or whether it does actually help for something to reproduce or not. I have some silly ones in there, but generally they should arrive at the same conclusion, because if even one of those things is off, they should really reconsider maybe this isn't actually an adaptation because one of these key components is actually missing. So it's very simple, but it's a great kind of either front end or book end, depending on how you want to use it. So you can use it as an assessment, or you can use it as an opener. And as an example, I actually adapted it, and I will include this resource as well, free, because I don't know, it's just pieces of paper with situations on it, where I actually included these aspects in a cutout form, where I just simply had students, without going into what an adaptation was, without discussing it yet, I introduced it by giving them these situations, the exact same situations that were going to show up on this worksheet, and they had to sort them into yes or no, right? It was a very simple dichotomous, yes, it's an adaptation, no, it's not an adaptation. And I had them think about why. And some of them intuitively started to feel that there were patterns in some and things that didn't go with others. And so I thought that was helpful. Some are silly, some are more difficult. Some maybe confront them with ideas about the natural world that they didn't know, like snake pelvic structures. That's kind of a weird one that some kids are often mind blown by, and I think that's fun. But it allowed them to kind of sort that. And after we had gone through a couple of days of talking about adaptations, then I was able to share that final worksheet and use it more as a final assessment. So you can use it, again, as a summative or formal assessment in lieu of doing it as a pre-assessment, or you could do it as a pre-assessment both. There's so many possibilities. That's why I call these lesson seeds, because I want you to be able to take it and adapt it to your situation and what you need. The second thing that I have shared is that I made a more official owl pellet dissection lab. It's very simple. I kept it at a middle grade level. I was student teaching a 9th grade remedial course, and those kids were amazing, but they had a variety of different abilities and skills, and so I needed to adapt it to a level that still allow them to interact with the vocabulary, and I made it more of a literacy lesson where I introduced a little bit of a reading section where the students read, where they evaluated what they read with some questions that kind of prompt reading analysis. And then finally they kind of went through the owl pellet lab, and so there's lots of adaptations for the I use the word adaptations. There are a lot of different ways that people have done the owl pellet lab, so I'm not including like how to do the lab itself. I just kind of simply made a pre-lab literacy section. I made through the lab, I wanted my kids to be able to practice identification. That's something I think is very important and a helpful skill that I think can go on to other things. And so I made them kind of check off like what they caught from their little pellets, what they actually got out of it, how many of each bones, kind of trying to interpret what they found, and had a reflection based off of that. It's very simple, but it can easily be compounded with other things. The actual dissection itself takes a while, and so that's why I wanted to leave it simple and allow it mostly for the students to work on their identification, work on their actual lab skills. This would be a great one to introduce students with. I introduced this as one of the first labs that we did because, again, I didn't know what their skills would be, and this takes relatively few tools. So for example, you can have just a single owl pellet, which is, kind of just like a little chicken nugget, a little bit. And you can just have like tweezers and a skewer, or just tweezers, or fork and a spoon. You can use lots of different tools, and so it's a very easy introductory lab to kind of just see where students are and to get them kind of excited about what we can do. And also, it's cool because owls are cool, and they get kind of mind blown. A lot of kids have misconceptions thinking that owl pellets are poop. It's not poop. And so you can discuss that a little bit. I also love throwing out words like proventriculus and gizzard, and it's a really fun lab that my students really enjoyed when I was student teaching. And finally, the other cool tie-in with that is that if you do the owl pellet lab, I would really encourage you to encourage your students, or if you want to, the Guardians of Gahul series is one of my favorite book series of all time. And that's just a wonderful book. Even though it's fantasy book, they're relatively short, they're easy to digest, but they do actually have Catherine Lasky, the author, really does actually put in real science facts about how these owls live. And the very first chapter of the book talks about a pellet ceremony that one of the owls partakes in. So it actually describes this owl barfing up a pellet, and I think it's a really fun way to introduce kids to, not only stories with kind of science tie-ins, but also just kind of how they can see these science things in different ways. So I really love when fantasy books kind of introduce students to the natural. So one final thing that I like to include is that I made a visible thinking strategy, which I hadn't seen one like it before, so I'm not trying to be original or novel. It was just something that I thought of that I hadn't quite seen, and it has helped me because I've used it several times with different vocabulary words, and I find it pretty effective, is that I take students through a chart that I've been calling comparative notes, and it allows me to, one, have the students guide through a website or textbook definition of a word. So let's say we're doing the word adaptations. I would take them through the textbook definition, a textbook example. And then I would also take them through a textbook bad example and explaining why that example is bad. And you can find a lot of those online. Again, the Berkeley site of Understanding Evolution is really excellent for a lot of these misconceptions with evolution or ecology-related words. But that said, they also then go through a teacher or a group defining period. So it's the same things where they have to define it, find a good example, a bad example, and explain why that example is bad. And I have done it as a teacher where I give them my definition, which simplifies it. And for me, that's helpful for me because I really love the content, and ecology is really my forte and where I've spent the most time in my own science career, and so I feel really comfortable being able to do that. But you can also use that as a time, depending on your students' needs, or to even just switch it up a bit so that the students aren't doing the same thing if you're doing it again but with a different word, where you could actually have them group construct their own kind of synthesized definition using their textbook or website definition, where they kind of synthesize it kind of to a more layman's level. So that's kind of the goal. And then ultimately they do it on their own as individuals, where you can actually assess to see if they really understand it. Because again, one of those things that we often learn in our pedagogy classes is if you can teach it, you understand it. Typically, if you are able to explain it to someone else in a way that is understandable, they are also able to understand it. And so this kind of takes them through that process, maybe without them knowing, but also it has some other metacognitive effects, such as taking them through kind of the bad examples and why those examples are bad, helping them to see those patterns and to be able to recognize errors, which is a very high-level strategy. But the way that I've made the graphic organizer is very basic and simple, so it allows students to kind of read, even draw if that helps them, and kind of easily take them through that process. And finally, I do have them make a sentence for each. Sometimes that's helpful, sometimes that's not. I'm not always consistent with that, but I leave it in there because I still think it's helpful for students to kind of ultimately synthesize what they've been learning and what they've been talking about. So that's just a snapshot of adaptations, just a little review, just in case you're having to teach it tomorrow because all of a sudden you're, I don't know, maybe you just got hired mid-year and you're freaking out. Yay! But also just, it's helpful to have that refresher, and I'll provide these resources on my website. I'll provide those links. And also, if I have a lesson plan available, I will give you maybe a sample lesson plan of how I might integrate this into a fuller classroom. And I'll let you know ahead of time that time management is really not my greatest thing. I'm very contiguous and thematic in how I think about things, so you'll have to take that with a grain of salt when I put time in my lesson plans. But I will provide that so that you can get an idea of how I would put it in my classroom so that you can maybe adapt it for yours. So, goodbye world.